Bismillahirrahmanirrahim. In this tutorial, we will discuss PLC inputs and outputs. Inputs and outputs of PLC are of three types: digital, analog, and frequency. Digital inputs. A digital input could be a switch or a sensor which has only two states, that is on or off. When it is on, it is 24 volt DC in case of PLC, and when it is off, it will show a 0 volt signal. Symbols for digital inputs for PLC ladder programming are: this is one side is common, the other side is normally open. This is one side is common, other side is normally closed. So this is normally open, this is normally closed. And in case of a physical switch, you can see that this is the common and this is the normally open switch, and this one is the normally closed. This is the common, this is normally open, and this is normally closed. When it is turned closed, then this switch will be attached with this and this will be turned open. So these are different kinds of forms of the switches. Normally digital inputs for PLC programming are designated with some alphabetical letters like I, A, X, etc. Or we can give a particular name as per our application: motor on, motor off. Inputs are represented with different PLCs with different addresses like I, A, X. In case of Mitsubishi, we represent the input with X. In case of Siemens, we represent the input with I. And in other cases, we also designate with a different name and letter. And the outputs are also designated with different kinds and different letters in different PLCs. PLC input and outputs. Digital outputs. A digital output could be a lamp or a relay, alarming device or contactor which can be switched on or off. Symbol for digital output for PLC ladder programming is coil. This is the coil, this is the coil, and this represents the output. Above symbol is common for all types of PLC programming software. It represents the coil of a relay or a contactor. It is a coil of a relay or a contactor. Normally digital outputs for a PLC programming are designated with some alphabetical letters like Q in case of Siemens, Y in the case of Mitsubishi, and B in case of Allen Bradley. Or we can give a particular name as per our application like motor, main pump. We can also write a comment on the inputs or outputs to designate its name, for example main motor, main pump, etc. Input and output signal to a control system can be divided into two groups: digital and analog. A digital signal has only two states, 0 or 1. 0 and 1 correspond to voltage levels and can have different potential levels for 1. For example, status 1 could be 3.3 volt DC, 5 volt DC in case of microcontroller based systems, and in case of CMOS system it would be 12 volt DC for CMOS digital system. For a PLC control system, status 1 corresponds to 24 volt DC. These voltage levels are true for both input and output signals. Input-output signals are represented with different voltage levels for different cases. In case of CMOS, it would be 12 volt for 1 and 0 volt for 0. And in case of PLC, it would be 24 volt for 1 and 0 for 0 volt. And in case of microcontroller, it would be 3 volt or 3.3 volt or 5 volt representing 1. This is the level 0 and this is the high level. In case of 1, 3.3 volt, it represents the microcontroller based system. 5 volt also represents a microcontroller based system, and 24 volt DC is the PLC based system. These are the inputs: push button, toggle switch, limit switch. These are the outputs: LEDs, solenoid valve, and this is the relay. Example of digital input and outputs could be switches as input and a relay indicator as output. These are the switches and these are the relay indicators. An analog signal can have many values between minimum and maximum value of input or output signals. For example, minimum and maximum voltage levels as analog input or output could be plus minus 3.3 volt, plus minus 5 volt in case of microcontroller based system. The maximum voltage would be plus 3.3 volt and minimum voltage minus 3.3 volt, or plus 5 volt is the maximum voltage, minus 5 volt is the minimum voltage. For a PLC control system, minimum and maximum levels for an analog signal could be plus minus 100 millivolt, plus minus 10 volt, plus minus 20 millivolt. These are in case of current, and this is the voltage level in case of voltage. When you take a signal in the shape of voltage, the plus minus 10 volt will be its maximum minimum range. If you are taking a signal in case of millivolt, in case of current, then a plus minus 20 millivolt will be its maximum minimum range, and plus minus 100 millivolt is also the voltage level for the analog signal. For example, these are the analog inputs devices. Maximum and minimum maximum ranges: plus minus 3 volt, plus minus 5 volt, plus minus 10 volt, plus minus 20 milliampere. Example of analog input and outputs could be temperature. This is the temperature. Speed of a motor. This is the motor. and flow of liquid or gas. This is the flow sensor, and its maximum and minimum ranges are given here. This is the flow sensor, this is the temperature measuring sensor, and this is the motor. PLC architecture, we have already discussed it. There is a central controller which consists of microcontroller, and the analog input and digital input are placed on the one side. Analog output and the digital output are placed on the outside, other side. Then when the sensors turn on these analog or digital inputs, then this signal passes through this controller to the output. In case of analog, to the analog. In case of digital, to the digital output. Then actuators, motors, valves, LEDs, contactors will be turned on, and the same time the feedback will be given to the input sensors to control their positions. A field bus is connected from this point to connect this PLC with the other PLC units. PLC programming languages, as we have discussed earlier, all around the world, ladder logic is the most popular method used to program PLC. Other programming methods include statement list and function block diagram. Three kinds of programming languages: ladder language, statement list, and the function block diagram. As we have already discussed these languages in detail in other videos, you can see those videos also on my channel. Input and outputs in a PLC program. Step 7 microvin. This is the Siemens PLC software. Step 7 microvin. Input is represented with I, and the output is represented with Q. Q 0.1, Q 0.2. These are the outputs. Input is I 0.7, I 0.7, and these are the normally closed inputs, I 0.6, I 0.0. These are the all inputs, I 0.1, I 0.2, and this is the contact of the output, Q 0.1. This is again the contact here, contact of the output, Q 0.2. Mitsubishi PLC compiler GX developer. This is the GX developer software that we have discussed in details, and we have complete series of Mitsubishi PLC programming videos. You can also check it out, and the link will be given in the description. These are, in case of Mitsubishi, input is represented with X, X0, X1, X2. Also, the output is represented with Y, Y0, Y1, Y2, Y3, Y8, and so on, Y80. And these are the M0, M1, M18, M2 are the auxiliary relays used to program. FATIC WinPro ladder PLC programming software. In case of FATIC, input is represented with similar M, and input is represented with X, and output is represented with Y. And M1, M2, M3 are the auxiliary relays in case of FATIC. This is the Rockwell automation Allen Bradley. In this case, input is represented with I, and output is represented with B. These are the outputs. Output is represented with Q. Input is represented with I, and output is represented with Q. And this is its programming method. This is a timer. This is again the timer contact. This is the output. Parts of automation. Digital inputs. Digital inputs are in the shape of push switch, miniature push switch, limit switch, push button, flow switch, the flow switch. This is the float switch. This is the photo switch, pressure switch, proximity switch. These are all kinds of switches and sensors are connected at the input. Parts of automation, digital output. Digital outputs consist of flow control valve, power relay, contactor, indicator lamps, relay, solenoid valve, audio alarm, solid state relay. These all the coil based objects are connected at the output. Parts of automation, analog inputs. Analog inputs consist of flow transmitter, temperature transmitter, quadrature encoder, techno generator, level transmitter, decision potentiometer, pressure transmitter, humidity transmitter. All these are the analog input devices. Parts of automation, analog outputs. Analog outputs consist of induction motor drive connected with the induction motor, DC motor drive connected with these are the different kinds of drives. We have discussed inputs and outputs, and now these are the drives. Induction motor drive is in this form. DC motor drive, this is the DC motor, and this is its drive. This is the BLDC motor drive, BLDC motor, and this is its drive. Heater drive, this is the heater, and this is the heater drive. Automation with sensors and actuators. This is a simple project. We use this project to run different kinds of sensor and actuators to control the program. For example, this is a gasoline tank, and here is a pump. When pump turns open, due to this is a PLC. Then the gasoline flows to this valve, and this is the valve. It's turned open, and here is some smart additives which are added to the pump, and then it comes here where the temperature is provided through a sensor to this mixture, and then a flow meter measures its flow. Then the mixture goes to the output for packing, and after packing it will be transferred or loaded to the truck for its delivery. This is the PLC unit. All the inputs and outputs are given its connection to the PLC unit. Designing and configuring of PLC system. This is again a PLC system. This is the physical PLC system which is placed in the field, and field connection are given to the PLCs, and PLC control all this plant. This is the plant, pilot plant, which is controlled by the PLC. Here the PLC S7300 is attached, and this PLC is connected with the CPU, with computer or the laptop, and the laptop is also connected with SCADA system, SCADA software, WinCC SCADA, and through SCADA system we monitor its inputs and outputs, what is going on its inputs and outputs. When a value changes on the input and output, we can observe it on our screen, and we can take a decision based on values of the inputs and outputs. This is the SCADA screen, which is placed in the control room to observe all the plant in a single glance. Similarly, this SCADA screen is also shared with the web server through Ethernet. It is also shared through mobile network, internet, and anyone can access to see the real-time conditions of the inputs and outputs from anywhere, from everywhere. For example, if your plant is in the Islamabad, you can check its values from Karachi, Peshawar, Lahore, everywhere. So this SCADA system is through internet connected with wireless systems, with also connected with mobile systems, also connected with Ethernet systems, web servers, and it can also be used to have a camera to record its monitoring, video monitoring. For video monitoring, we can also connect this system with a camera which monitors its values. So this is the real-time project connected with a PLC. In different kinds of projects, we have already made different kinds of projects, physical projects on my YouTube channel. You can check those projects, which consist of traffic light project, motor reverse forward project, and many others. I think 7-8 projects have been developed, and you can see all those projects. The link will be given to you in the description box. Thank you so much for watching this video.